In the last video, I talked about 3 of the 4 types of method references. These were relatively straightforward, but this last one can be harder to grasp initially. I'll start by talking about some terminology that should help you with understanding this last type of reference. A type reference refers to a class name, an interface name, an enum name, or a record name. Static methods are usually called using type references, but can also be called by instances in our code. This is not true for method references. Static methods in method references and Lambda expressions must be invoked using a reference type only. There are 2 ways to call an instance method. The first is when you refer to the method with an instance derived from the enclosing code. This instance is declared outside of the method reference. The system.out::println method reference is an example of this. You'll find that some websites call this instance a bounded receiver, and I actually like that terminology as a differentiator. A bounded receiver is an instance derived from the enclosing code used in the Lambda expression on which the method will be invoked. The second way to call an instance method is where the confusion starts. The instance used to invoke the method will be the first argument passed to the Lambda expression or method reference when executed. This is known in some places as the unbounded receiver. It gets dynamically bound to the first argument, which is passed to the Lambda expression when the method is executed. Unfortunately, this looks an awful lot like a static method reference using a reference type. This means there are 2 method references that resemble each other but have 2 very different meanings. The first actually does call a static method and uses a reference type to do it. You saw this earlier when I used the sum method on the integer wrapper class. This is a type reference. Integer is the type, which will invoke a static method. This is easy to understand. But there is another, which you'll see when I start working with string method references in particular. Here I show a method reference for the concat method on string. Now you know by now, I hope, that the concat method isn't a static method on string. It's an instance method that is called on a specific string object. So why is this method reference even valid? You could never call concat from the string class directly because it needs to be called on a specific instance. I just said not 2 slides ago that instance methods can't be called using reference types, but the example shown here is a special syntax when it's declared in the right context, meaning when it's associated to the right type of interface. This is valid when you use a method reference in the context of an unbounded receiver. Remember, the unbounded receiver means that the first argument becomes the instance used on which the method gets invoked. Any method reference that uses string : concat must be in the context of a 2-parameter functional method. The first parameter is the string instance on which the concat method gets invoked, and the second argument is the string argument passed to the concat method. Confused? Well, stay tuned, and this should make more sense when you see it in code. I'm going to invoke my calculator method again, passing a different Lambda expression. This Lambda will have 2 parameters, s1 and s2, and I'll use the plus operator on them, passing the strings hello and world as the last 2 parameters. This looks like a simple addition operation, but it's not, because we're operating on strings. The plus sign, when used with string operands, is a concatenation operator. Let me run this code to confirm what I just said. You can see that the result returned is indeed hello world. Next, I'm going to change my Lambda expression to use the concat method instead of the plus sign operator. I'll pass s2 as an argument. I'll run it now. And I get the same results. IntelliJ is requesting my attention, and sure enough, it's saying this could be a method reference, so let me take that suggestion. Does this method reference look confusing? Maybe not, since I just gave you a hint of what to expect on a slide in this very video, but wait, how does this work again? To show you how it works, I'm going to start by reverting that code change and move back to the Lambda expression. I'll copy it, then switch that copy to a method reference so you can look at both together. Notice how the Lambda expression is set up. It has 2 parameters, and in the code part on the right side of the arrow, the concat method is invoked on the first argument, s1. The second argument, s2, is passed to the concat method. This is exactly what the method reference will do implicitly because it's declared in the context of a 2-parameter function method. How's that again? The method calculator has as its first argument a binary operator. A binary operator has a method apply that takes two arguments of the same type and returns a result also of that same type. Make sense yet? Let me make this really clear by setting up a local variable with the type binary operator using string as its type argument. I'll assign it the same lambda expression I was using s1.concat, passing it s2. I could also make this a bifunction interface using string for all three type arguments, which is all the binary operator really does. I'll copy that last statement and paste it, changing the name to b2. I'll also change binary operator to bifunction, and I'll have to declare three types now because I'm using bifunction. The first two are the method parameters, both strings, and the last is the result type, so string again. I want to click on the gutter icon here on the bifunction statement line and show you the method apply that has two parameters. The two parameters in the targeted method is the very reason we can use a method reference like string : concat. Going back to the main method, I'll change both of those method references using IntelliJ's recommendation. What happens if I try to use an interface that has a method without two arguments? I'll copy that binary operator statement and paste the copy of it just below, then I'll change binary to unary and change b1 to u1. IntelliJ is giving me an error there on concat, and now it's complaining about a non-static method being called from a static context. Are you confused? Don't worry, this is definitely confusing and may be confusing for a while, but you'll understand if you stick with this. If I click the gutter icon next to the unary operator line, I can see the method. It's actually showing me the method onFunction, which ultimately unary operator is, but has the constraint that the return type equals the method parameter type. And you can see the method is apply, and it has only one argument. Only one argument is available to the method reference assigned to a variable of this type. With only one argument available, calling concat on the first argument would leave us with no additional argument to pass to the concat method, so it doesn't make any sense to use concat for this interface. Let me try to type this out as a lambda expression. So I'll pop back to the main.java file. This is an invalid lambda expression, and hopefully this is easier to understand. For a unary operator, there's no s2 available to it, so we can't set this up with s2, so I'll remove s2. Now you can see the lambda expression has no idea what the variable s2 is. This code doesn't work out of the box like this. Java figures all of this out and won't let us use string : concat for the unary operator, but I can call a method on string that doesn't take a parameter, for example the instance method, to uppercase. Let me do that now. That compiles, and I can now change that to a method reference, so I'll do that. Again, the implicit argument is used to invoke the toUpperCase method on. The good news is that Java and IntelliJ figured most of this out for us. The bad news is that this may be confusing for a while until you get the hang of this. I want to execute all of these method references next, so I'll call the apply method on each of these three variables, passing each to println. For b1 and b2, I'll pass two strings, hello and world. For u1, I'll just pass one string, hello. I'll run this now. You can see the three output statements at the end. The first two concatenated hello and world, and the second changed hello to uppercase. Before I end this video, I want to introduce you to another method on string, one I haven't shared with you yet. This method is named transform and takes first a function with a string type as an argument and returns an object. I'll use this to test a method references. First, I already have a unary operator variable set up which is a derivative of the function interface. This means I can simply pass my variable u1 to the transform method on a string. I'll set up a local variable result also a string and assign it the result of calling the transform method on the string hello, and I'll pass my u1 variable to that transform method. Print the result out. The transform method isn't required to return a string. It does in this case because I've defined the variable to be a unary operator with a string type argument. This means string is used as the argument and returns a string as well. Running this code now, you can see I get result equals hello with hello all in uppercase. Let me add another example. I'll pass a method reference directly executing transform on the result variable and passing it string : to lowercase. Then print it out. This will take the result and apply this method reference, making it lowercase, which you should see when I run it. And it's all lowercase. You're not restricted to returning a string from this method, by the way. Let's try another method reference. First, I'll create a function variable f0, which will take a string and return a boolean. I'll assign it string : is empty. Next, I want a boolean variable, and I'll call this result boolean, and that will get assigned the result of the transform method with the f0 variable on the result string. I'll print this out. You can see with this code, I'm specifying a local variable, a function with two different type arguments, string and boolean. The last argument describes the type of the result. I could have passed the method reference directly to the transform method, but I wanted you to see this declaration because it describes the result a bit more clearly. All of this could have been inferred by Java. Running this code now, you can see the last output statement where I got result equals false, and that's because the string variable result wasn't empty. Okay, so I hope that was interesting and helpful to you. This video is getting long. Don't worry if you feel a little lost still. We're going to be using lambda expressions a lot over the next sections of the course, and method references where appropriate. Make sure you pay attention to IntelliJ's warnings and hints, transforming lambdas to method references where suggested, because this will help you learn the patterns involved. I'll finish this video with a few slides for your reference. These slides are a bit hard to talk over, so I'll just display them. Let me encourage you to pause the video as you study them. This chart shows the 4 different types of method references with method reference examples and a corresponding lambda expression. This chart shows some of the valid ways to use method references when assigned to different interface types. These interface types have no arguments in the case of a supplier and one argument for the other interfaces. If a cell is empty, it's not because it's not valid, but because there are many possibilities. N/A means not applicable, so a supplier or an interface method that has no arguments can never be a target for the unbounded receiver type of method reference. This chart shows some of the valid ways to use method references when assigned to different interface types. These interface types have 2 arguments, and therefore it's more common to see the unbounded receiver method references used for these. In the next video, I'm going to give you a method reference challenge. Hopefully this will encourage you to get used to using method references in your everyday coding. See you in the next video.